All right. So this week's subject to cover is CI/CD pipelines. Let's cover what they are, what they aren't, best practices, and so forth. All right. So CI/CD pipelines are basically automations or workflows that are running whenever you guys are building code, testing code, and then deploying the code into different environments. A lot of the times these are built out in GitHub Actions or TeamCity or Jenkins or whatever other CI/CD tool is out there. So in the past, I have transitioned a bunch of different applications off of TeamCity over to GitHub Actions, so I do know the subject quite well. Just a little bit of background on myself. I've developed for the past 7 years. A lot of practices in different fields. I've seen what it looks like to deploy something without a CI/CD pipeline and also what it looks like to deploy with it. So here are the benefits. Automation, as in you're guaranteed to be able to test out your code in different formats. The other bit to this is testing. So seems like the same thing, but automation mainly means like you can set the workflows to run on cron schedules and check your dependencies folder for any new node modules that might be out there that need to be updated to ensure that your secrets aren't being leaked, or maybe there's a vulnerability in a certain package and they'll get updated. For testing, say you have a bunch of new code that's being transitioned to the application, you don't want to just deploy into production and then all of a sudden everything breaks. To cover what CI/CD actually stands for, think of continuous integration. And continuous delivery and continuous deployment. So that's what the next one is. Okay, so automation testing, another benefit to it is just accountability. As far as like security scans go, whenever you're introducing a new bit of code to something, you want to make sure that the code that you have doesn't introduce any new vulnerabilities into what you are running. So you have your automation, you have your testing, you have your accountability, all within this one pipeline. So let's take it back a step. What exactly is a pipeline? Think about it as a workflow or like a flow chart that's running step by step a set of instructions or jobs for the code that you're in. Yeah, whenever you're in the development cycle, you don't want to just, like I said, deploy this into production and not be able to know how it's going to act or how it's going to react. So typically we set this up into 3 different layers. You'll set up unit tests, and usually if you're on a new project, or on an existing project, you're already going to have these set up. Unit, integration, code coverage, and okay. So I said SQL, but it's usually like another layer of like end-to-end testing that you will have between teams. But regardless, you start off with the pipeline itself. What it usually does is has a rule inside your repo. Check out the repository, and then within this, it's check out the repository, check out the branch. It's gonna build it inside a Docker container. Build the code inside a Docker container or some other type of container for it to be able to run it, and then starts running tests. Or it starts running through, from this build, it'll run through a security scan of some sort, or it'll do like usually security scan, or it'll do like another one where like it's ensuring that you don't have any vulnerabilities within the Docker container. So some other type of scanning is going on. So usually what ends up happening is that you set up some code, you set up some unit tests, because that's usually where people start. Or it's the other way around with test-driven development, where you're setting up your tests first and then running the code, and you're expecting your actual code to be able to pass these tests. And then you deploy it into you deploy it via like GitHub Actions. Okay, so see, like Rust isn't really the best. Okay. Regardless, what it's doing, we check out the Rust, we cache it, so it doesn't. So the next time that this thing is running, it's not having to re-download everything. And I'll cover optimizations here in a minute. But then, like, we're checking format, we're checking the linter, we're running a test suite of like where it's like running the entire test, and then run another test suite, ensuring that everything ran. And then making sure that zero's okay, like everything passed. If there is a test to be had, so here, 6 passed, 0 failed, we're good to go. And usually what ends up happening is that you set up a pull request for a branch, and then within there, once you set up the pull request, it'll kick off a automated pipeline. And this in itself will start running through this whole process. So that's continuous integration. The reason why we want that is because, hey, whatever you're deploying, you're basically having the accountability to make sure that like your code is actually running proficiently and correctly, and then you're saying like, hey, no, there's not going to be any issues whenever I go to deploy. Now, for continuous deployment, the other part of this is, say you want to be able to run all these tests. You knew that everything's going to do good, but you're going to deploy into like some type of lower lifecycle environment. And when I say lower lifecycle environment, it's an environment that is not production as far as like the whole public can see it, but an environment that maybe is internal that you guys are able to visualize. Now, this can be a separate Google Clouds project. It could be an AWS project that you guys have access to, but it's somewhere out in the cloud or maybe internal that you guys are deploying to, running your tests, and it's either called non-production or QA, as in quality assurance, that you guys are deploying this code to. And it's just one extra step into your pipelines that you're running, and you're being able to show like, hey, this is actually deploying. Now, this is broad because I don't know y'all's use case for this, but basically here's what the pipeline is. As far as like, we check out the repo, we run some tests, we ensure that security is running, pull request is approved, you by your team, and then you go to deploy into production. And that deployment pipeline just depends on where you're deploying to, via Google Cloud Run, via something else. GCP is my stack, so I would say you're deploying to Kubernetes or somewhere to that effect. Now, here's the fun part about these pipelines is over time, new scans are being introduced by different teams, especially in the world of AI. We're being told, hey, we have this new scanning tool that needs to be able to scan your code. You need to be able to like go in and actually add this to the pipeline itself. And for that effect, let's go look at what an actual pipeline looks like. And okay, so you're going to have them inside of a .github workflows file or workflows folder, and then it'll be a YAML file. YAML's what GitHub Actions typically uses. Now let's just break this down step by step. So anytime that we're pushing to the main branch, or we're having a pull request on main, this pipeline's going to get kicked off. What this does, or what this is currently doing, is setting up environment variables, and then we're having our jobs, our list of different jobs. Check and test is the first job that's running. We're running on the different Matrix OS. We're running it on Ubuntu latest, Mac OS, and Windows OS. And for y'all that don't know, these are basically different containers or different operating systems that this thing is running in. So basically, I don't want to have to, like, back in the day, you would have to like port your application over, build it in some type of binary, and then move those files over, or take your source code and move it over onto those computers and then build it from source. This way it takes away from that, as far as like you're able to no longer have to deal with that. You can just tell it, hey, go build it inside of Ubuntu, Mac OS, or Windows, and it'll go do that. And then you're telling it, hey, use the stable version of Rust. Okay, this is now, here are the steps for this job. You're gonna check out, for this job. So you're gonna check out the repository using GitHub's like built-in checkout steps. You're gonna set up the Rust toolchain using whatever way that you guys are setting this up, and then you're telling the matrix, hey, whichever one that the matrix, basically any operating systems you're doing it, and then components, Clippy, or Rust format. You're caching it, so if you have to rerun it, it's already in memory, and you don't have to re-download everything from scratch. You're gonna check code formatting. You're gonna run through Clippy, and then you're running your test suite, basically ensuring that you can see everything that's going on. Now, this is a very basic versioning of a pipeline. For deployment, say you're actually going to deploy it into a server, you would have like a separate job in here that would deploy, and then for you would have a separate job as well for like releasing it onto GitHub Actions release. So format would go code, scanning, run through tests, release on GitHub, and then deploy into whatever environment, or pre-release and then deploy. So I know I'm covering it pretty quickly, but I did want to be able to like cover this in the way that like most people understand it. All right, the parts that I really want to cover are, hey, what happens over time with these pipelines? Do they need maintenance? Do they need something else? You would just basically add another job or another step inside of here to be able to create those scans. But all of this does take time. All of this, as far as like building from scratch, running tests, and you'll see a bunch of times that, you'll see a lot of the time that these things, especially when it comes to testing, could take a very long time to do. The whole point of this is to be able to save time. And it does, but also sometimes it doesn't, because say you have integration tests that are reaching out to a BigQuery database, and you would think, okay, well, we can potentially just unit test that, but if we really want to make sure that this application is not going to break production, we're going to ensure that we can run those integration tests. The optimizations that happen are whenever we run this in parallel, so we break out the testing to no longer have to be, hey, I have to run this sequentially, run these tests, these tests, these tests. Instead, what we do is that we can run these in parallel. Granted that you wrote your tests to not be dependent on one another. Writing good tests really does matter in this sense. You're going to run all your tests in parallel. That way, you're not waiting on this like unit test to finish, integration test to finish, and whatever other tests. You could run these in parallel. Now, the other thing that you can do is run your scans in parallel, meaning you have some type of AI scanning tool here, and some type of security scan. Usually what would happen is like tests have to run, then scans have to run. But I disagree with that. I say you can build, and then you can also, while this thing is running, you could invoke your scans at the same time. And that's just telling it, hey, go ahead and do this. And you would probably wondering what that looks like as far as like in here. I don't think I have a repo available to me right now that I have that, but you basically don't have to go through like step by step line wise. What you guys can always do is have this set up in the sense of like, okay, this job is running, you could have a second job underneath here, and usually they have depends on this job, but if you don't have that depends clause inside of it, it'll kick both of them off at the same time, and then you don't have to be waiting on like matrices also help with this. Let's see if I have it. See, for this instance, these 3 jobs kicked off at the same time because we were using matrix, but you don't have to use the word matrix to be able to run them at the same time. You can just not have a like depends on clause inside of your jobs and it'll kick off all of them. So that's one aspect of CI/CD pipelines, especially in GitHub Actions, where like you can save time running these things in parallel. All your unit tests work, awesome. All your integration tests work, and then whatever other testing, and then you can look at your scans and start digging deeper into whatever your pipeline might be doing to be able to determine like, hey, this is working, this is not working. Say an integration test fails, you can zero in on like which one failed and what's going on, and you know that your unit tests worked and all this other scans are working, so you can just focus in on that one aspect or that one test. And I would recommend having like a pipeline where like it can build your code and then just run one singular test suite or test itself. That way you guys aren't having to rerun all of this at the same time, because that costs money as well, guys. That's tooling and computers and that are running this in the background that it's costing you time. I don't know how much GitHub charges you for it, as far as like depending, they have their own like setups as well. But really quickly, I did want to cover, I know I'm all over the place, so I'm sorry. Runners are basically just either computers or containers that are like waiting for GitHub to call them to kick off this pipeline. So like launcher of some sort, I'm gonna call it launcher. It's whenever you push or pull to create a pull request, the runners are waiting, and if the runner is available, it'll kick off it'll get the set of instructions on what to do. This goes into here, and it goes into this whole like, okay, pipeline that it needs to run. But these things cost money because they're virtual machines or they're some type of container, but they're all running on CPU power, and somebody has to front the bill for this stuff. It's not free, unless you have like your own local machine and you're running these pipelines on your own stuff. Then you're just paying for electricity at that point. But all this to say, you don't have to just have to take what it is. There's many times in the past where like I have looked at pipelines and I have seen like historically that the tests were written in something that is now outdated and you need to rewrite your tests altogether. Or there's other times where you're running these things in like sequentially, like unit tests have to complete first, then integration tests, then something else, and this takes time, dude. Like hours. And you don't want to be doing that. You want to be able to like run these things at the same time. That way you're not hitting rate limits, as well as like you're not hitting in other stuff. So this is all I'm going to cover tonight. I know it's a lot. I know that I covered a lot as far as like what this is, but I do want to challenge y'all to like go out there and try to build your own pipelines, as far as like, or have Claude build it for you and then just try to break it down, or tell Claude itself is like, hey, I need to know what this pipeline's doing. That way you can interact with it, because the other parts of this is like maybe you're using an action that is outdated and needs to be redone or replaced by something else, or maybe you're using a scanning tool that takes like 3 hours to complete and you're just like, no, I'm not dealing with that, let's do it some other way. So there's multiple tools, multiple things out there for you to do. I do challenge y'all to go try this stuff out, and more importantly, I think GitHub gives you like 2,000 hours free to be able to like play around with it, and not an advertisement to GitHub. You guys can use any other pipeline tooling. Just make sure it's free while you're playing with it. That way you guys aren't wasting your money. So I appreciate the time. I hope this helps somebody out, and I'll see you guys in the next video. Bye.